In 11.3a, we're doing a confidence interval for the difference between two proportions. So we're going to jump straight into an example. So two methods to treat warts are to freeze them or to put tape on them. Duct tape is said to remove 50%, while freezing removes 60%. So we are going to investigate the sampling distribution of the proportion for freeze minus the proportion for tape. So you guys should be familiar with sampling distributions by now. Suppose we took a sample of 100 warts and we calculated the proportion that were successfully removed using tape. And we did that with another 100 warts, and we did that over and over and over, and we found the p-hat for that 100. Then we would have the sampling distribution of p-hat for tape. And then we did the same thing for the freeze method. So we would have two sampling distributions, one for the tape method and one for the freeze method. Okay, we know that the true proportion of warts that are removed by freezing is 0.6. So we know that this sampling distribution will be centered at 0.6. Okay, recall that the standard deviation for that would be and the formula is radical PQ over N. So P is 0.6, Q is 0.4, and we did this for a sample of 100. Okay, so remember, the standard deviation for a proportion is radical PQ over N. The standard deviation for the number of successes is radical NPQ. Okay, for this other method, the tape method, we know that the sampling distribution will be centered at the true proportion, 0.5. This will have a standard deviation of P is 0.5, Q is 0.5, and N is still 100. Okay, so that was review. What we're doing today is we're finding the difference between those two proportions. So we're going to randomly take one proportion from the freezing treatment and one proportion from the duct tape method. So if we did that repeatedly, then we'd have the sampling distribution for p-hat freeze minus p-hat tape. So if the freeze method had a true p of 0.6 and the tape method had a true p of 0.5, and we subtract it in this order, freeze minus tape, we know that on average that would equal 0.1. So the average difference would be 0.1. 0.6 minus 0.5 is the average difference. The standard deviation for that, standard deviation for p hat for the freeze minus p hat for tape, right, that standard deviation would equal, and this is the Pythagorean theorem of stats. You take the standard deviation for freeze, which is Okay. Now, the standard deviation has a radical over all of that. But we don't want to add the standard deviations together. We want to add the variances together. So if I write it without the radical, that will serve as squaring it. So now I take not the standard deviation for tape, but the variance. So I leave the radical off, I add them together, and then I take the square root to turn it back into standard deviation. So if you do this on your calculator, you will get that this standard deviation equals 0.07. Okay, now let's move on to the back side of the notes. So on the front side, all we learned was how to find this and how to find that. So the way you find the mean is you subtract the two p-hats. The way you find the standard deviation is you add their variances together and you take the square root. Alright, so if you're going to carry out the whole process though, you're going to have to start with conditions. So the first condition is random. And something important to note is that this could mean random sampling, or it could mean random assignment. You need to specify which one it is. For the wart example, that was random assignment. They needed volunteers that had warts. They randomly assigned what treatment they were getting. And then if not random sampling or assignment, saying that it's representative of the population. Okay, condition 2. Same as before. NP has to be greater than or equal to 10, but there are two samples now, so we're going to make this N1P1. And then you also have to do it with Q. N1Q1 has to be greater than or equal to 10. And then you have to do it for the other sample. So from sample number 2, N2 P2 has to be greater than or equal to 10, and N2 Q2 has to be greater than or equal to 10. Condition 3. Samples are independent. And now the sentence after we check the conditions is going to be, since the conditions are met. Remember that proportions use a normal model. And we're going to compute a 2 prop z interval. So now we're ready to carry out the whole process. Okay, in this study, high school students and high school teachers were asked whether they agreed with the following statement. Students should be allowed to report controversial issues in their student newspapers without the approval of school authorities. 58% of students surveyed and 39% of teachers agreed with the statement. They had 10,000 high school students and 8,000 high school teachers in their samples, and we're going to compute and interpret a 90% confidence interval. So let's start with the conditions. There are no hypotheses because we're doing a confidence interval, so we start with conditions. First condition, random. They don't say anything, so we're going to have to assume this one. For condition 2, we have to check NP and NQ for both samples. Okay, so we're going to take N, and remember that for confidence intervals you use P hat. For hypothesis tests, use P from the claim. Alright, so we'll let this one be for students. We had 10,000. %, said yes, 42% said no, so we had 5,800 and 4,200, which are both at least 10. Now we have to do it for the teachers. So there were 8,000 teachers, and 39% said yes, so 61% said no. So we have 3,120 and 4,880. Okay, condition 3 is independence. They don't mention that, so we'll have to assume that one as well. Alright, that's all 3 conditions. So I made you guys show your work for the one sample hypothesis test and the one sample confidence intervals. For the two sample intervals, you don't have to show your work, but I'm going to show my work just so that you guys can see it for a multiple choice question. So the proportions were 0.58 and 0.39. We subtract those to find the average difference. Okay, the next thing we need is a z-star. They asked us to find a 90% confidence interval, so we're going to do inverse norm. We use inverse norm for proportions, inverse t for means, inverse norm. So if 90% is in the middle, that means 5% is in each tail. So inverse norm 0.0501. And that gives us negative 1.645. Okay, so the standard deviations, you multiply the proportions together, but we actually don't want the standard deviations, we want the variances. So we're not going to put it under a radical. There were 10,000 here. Though we're finding a difference, you still add the variances together. Okay, so my work is shown, and now you could let your calculator find the interval for you. So we're going to go to Stat, Tests, and if you scroll down to B, you'll see 2 prop z int. Okay, so x1 was 0.58 times 10,000. If you do this and it ends up not equaling an integer, you need to round to the nearest integer. It equaled 5,800, so we're good there. N1 was 10,000. X2 was 0.39 times 8,000, which equals 3,120. And N2 was 8,000. Our C level we want to be 0.9 and calculate. So we get that the interval is 0.1779 to 0.2021. So now we just have to interpret our interval. Okay, I won't bore you with watching me slowly write the statement. There it is. And once you're done writing it down, the lesson is over.